Module 1 Geomorphology. Now, let's study the interior of the earth. The landforms, whether it is a mountain, a valley, or some other kind of relief features, all these are directly related to the interior of the earth. One important question is, how do we know about the interior of the earth? For this purpose, we have two types of sources. First source is the direct one, which includes deep drilling projects and volcanism. By analyzing the different types of rocks came out through these, we can understand the constituents of the interior. The second one is the indirect sources, that is, the analysis of properties like temperature, pressure density, gravitation, magnetic field, and seismic activity provide information about the interior. Also, meteors are the next important indirect source. They are found to have similar structure as that of Earth because probably they were born together at the time of the beginning of the universe. Based on these studies, Earth is broadly classified into three different layers: crust, mantle, and core, each having varying properties. Inside Earth, temperature and pressure increases with depth. Now, the first layer is the crust. The depth of the crust is 0 to 100 km. It is the outermost solid part of the Earth. It is brittle in nature, covers 1% volume and less than 1% mass of the Earth. Thickness of the crust varies under continents and oceans as shown in the figure. Continental crust is thicker as compared to oceanic crust. Width of oceanic crust is 30 to 50 kilometers and continent is 50 to 70 kilometers. It is more thicker under the large mountain system such as Himalayan mountains to 70 kilometers. Continental crust consists of silica and aluminium. If you pick the first letters of silica, that is Si, and aluminium, Al, we can make a mnemonic code to remember it easily: Cl. Continental crust is made up of granitic rocks. Oceanic crust consists of silica and magnesium. Si plus Ma, that is Sima. Oceanic crust is made up of basalt rocks. Mean density of continental crust is 2.7 gram per centimeter cube and that of oceanic crust is 3 gram per centimeter cube. The next layer is mantle. The depth of the mantle is 100 to 29,000 kilometers. It is in solid state and covers 83% of volume and 68% of mass of the Earth. It is the most voluminous portion of the Earth's interior. Density 4.6 gram per centimeter cube. Its constituents are magnesium and iron, that is mafic silicate minerals. Asthenosphere is the upper portion of the mantle with a density 3.4 gram per centimeter cube. Astheno means weak. Why so? Asthenosphere found to be in plastic stage because of the presence of radioactive materials like potassium and uranium. These materials generates thermonuclear reaction, thereby produces heat. Hence, due to this heat, the materials in this layer is in semi-solid state or plastic state. crust and uppermost part of the mantle is called lithosphere. Mantle is the source of endogenic forces. The plasticity of the upper mantle is responsible for the movement of plates. Plate movements we can study in the next module. Next layer is core or barysphere. The depth of the core is 29,000 kilometers to 6,378 kilometers. It covers 32% mass and 16% of volume of the earth. It is divided into inner core and outer core. Inner core is in solid state and outer core is in liquid state. The density varies from 5 to 13 gram per centimeter cube. Core is made up of very heavy materials, nickel and iron, knife. The inner core is in the solid state, whereas the outer core is in the liquid state. The liquid iron core creates a magnetic field as the fluid flows around the solid core and interacts with the Earth's existing magnetic field. This process in turn generates a dynamic energy condition that maintains the Earth's perpetual magnetic field, that is known as geomagnetism. The next important point to be noted is discontinuities in Earth's interior. CMRGL is a mnemonics to remember these discontinuities in the order. The first discontinuity is Conrad discontinuity. It lies between upper and the lower crusts. The second discontinuity is Moho discontinuity or Mohorovic discontinuity, which lies between lower crust and upper mantle about 100 kilometers depth. The third discontinuity is Rapeti discontinuity, which lies between upper and lower mantle. The fourth one is Gutenberg discontinuity, which lies between lower mantle and upper core. The last one is Lehmann discontinuity, which lies between outer and the inner core. You can easily remember these discontinuities using the code CMRGL. C for Conrad discontinuity, M Moho discontinuity, R Rapeti discontinuity, G Gutenberg discontinuity, L Lehmann discontinuity. Thank you for watching.